Envision an epic ensemble played by an unfathomable number of stars, planets, and moons, all proceeding as a bound-together opening. Anyway, there is one express region of this gathering that has confused cosmologists for a truly drawn-out time interval: exoplanets. Exoplanets are commonplace planets that exist outside our planetary system, stowed away somewhere down in the Milky Way. You may be shocked to find that among the tremendous number of cosmic articles, there are exoplanets so like Earth. So the story heads off in an unforeseen path, especially like in any sci-fi thrilling ride. Specialists utilizing the James Webb Space Telescope found something astounding from Proxima b, a transmission so odd that it moved all through the educational areas in casual networks. It was named a potential technosignature. It was an electromagnetic spread so confounding and gigantically arranged that it could show the presence of a high-level civilization. The joint heartbeat of humankind seemed to stop at the zenith of a revelation that promised to alter our perspective on reality. Could the transmission any time be the sure proof that we are not alone in the universe? As fast as it seemed, the transmission vanished without rehashing the same thing, abandoning not just a staggering quietness, but also a labyrinth of unanswered inquiries and pervading hypotheses. Was it just a transient boundless characteristic, a setback of God's strategy, or something more purposeful, a coded message, or even a transmission of a disturbing boundless center? The singular mission cast a shadow of issue over Proxima b, starting a cutoff discussion on a fundamental level. Was it simply a passing irregularity, or is it a piece of an unending record clearly more perplexing than we can envision? In any case, stand by. The record, a wound-around masterpiece of our unlimited assessment, is unfinished. The ink has not yet dried, and new portions are still being made. This time, it isn't only normal researchers but also Harvard specialists who are driving a change of viewpoint as we continue our search for extraterrestrial life. They are not simply focused on studying the signs and qualities we have concentrated on up until this point. They are expanding the game by changing the James Webb Space Telescope into a kind of enormous night vision telescope. They need to look for artificial light sources in both the weak and illuminated areas of far-off universes. We're looking at ideas such as the chance of recognizing regular varieties of metropolitan locales glowing in absence of definition, like brilliant SVS. Imagine seeing the bright shafts of what could be a city murmuring with the presence of a high-level civilization, radiating its glimmer into the immense, gaudy seas. As we continue to unravel the mysteries of the universe, the journey for extraterrestrial life takes on new perspectives. Beyond the brief interest in Proxima b, our enormous pursuit dives deeper into the giant expanses of space. This pursuit is driven by both technological advancements and a colossal interest in our place in the universe. Consistent progressions in cosmology and space exploration have provoked the discovery of various exoplanets with potential habitability. Instruments like the James Webb Space Telescope, JWST, and ground-based observatories have stretched our capacity to perceive and analyze these far-off worlds. One especially fascinating field of study is the quest for biomarks of life. Profiles of signature engravings could include air gases like methane or carbon dioxide, which in the right circumstances could suggest organic cycles. The JWST limits interface past basic discovery. Its high-level instruments can measure the air composition of exoplanets with superb accuracy. By investigating starlight that passes through an exoplanet's atmosphere, experts can recognize chemical marks indicative of life. For example, the presence of water vapor, alongside other key molecules like oxygen or ozone, could indicate the potential for life-supporting conditions. One more road of examination includes studying the states of these far-off worlds. Ecological models, other than the possibility of technomarks, have gained some decent momentum. These indicate advanced civilizations that may be discernible through artificial designs or trend-setting technology. This could include structures like Dyson spheres, speculative forms designed to capture a star's energy, or unusual patterns in radio transmissions. As we advance our observational methods, the quest for technomarks could uncover the presence of extraterrestrial intelligence, not just enduring technological developments. Global joint endeavors are fundamental in the journey for extraterrestrial life. Collaborations between space agencies, research institutions, and private organizations improve our capacity to explore space. For example, missions to Mars and other celestial bodies consolidate contributions from various nations, pooling resources and expertise to achieve shared goals. Public engagement and education play pivotal roles in this journey, and the energy surrounding space exploration spurs the future of researchers and specialists. Effort programs and educational drives help to cultivate an interest in STEM fields and encourage teenagers to pursue careers in space science. The progression of new technologies also adds to how we might comprehend the universe. Advances in telescope design, data processing, and computational models improve our ability to perceive and analyze distant exoplanets. For example, cutting-edge space telescopes like the Extremely Large Telescope, YELT, and the Habitable Exoplanet Observatory, HABEX, promise to reveal much more detailed views and deeper insights into the potential habitability of exoplanets. As we push the furthest reaches of our knowledge, every discovery prompts new inquiries and areas for investigation. The quest for extraterrestrial life isn't just about tracking down alien civilizations, but also about understanding the origins and potential diversity of life in the universe. It challenges our perception and expands how we could interpret being alive. The exploration of exoplanets and the quest for extraterrestrial life are dynamic and evolving fields, with each step edging us closer to answering some of humanity's most profound questions. As we continue to explore the universe, the opportunities for discovering new forms of life and understanding our position in the cosmos remain endless, tantalizingly similar yet bafflingly different. It may be our planet's great twin. We dive into the entrancing area of Proxima b, found 4.2 light-years away. The James Webb Space Telescope shapes our journey for a comprehension of these divine riddles. Imagine a moment when your mind traverses the vast, grandiose space of our system, the Milky Way, which is home to in excess of 250,000,000 exoplanets, that is one followed by 15 zeros. To place this number in context, if each of these exoplanets were the size of a grain of sand, we wouldn't fill the Grand Canyon. We would have enough to create another milestone on Earth, a Grand Canyon 2.0 that would stretch out for a tremendous distance. It's also amazing that around 20% of these divine bodies have been considered Earth-like in terms of geological and biological design. That means there is a 1 in 5 chance of finding a twin of our planet. And the story doesn't end there. Alongside these planets, there could be another quadrillion moons, roughly satellites like our moon, participating in gravitational interplay with their parent planets. If you somehow manage to find another body in space that harbors life, or possibly could, the universe offers a surge of opportunities. Since we have spread out the material of immense scope, now is the time to present the masterwork to paint its diverse subtleties, the James Webb Space Telescope. This sublime Sherlock Holmes, with its magnificent focal length displaced by adaptive optics, outflanks even the most advanced Marfan optics. We're not talking about any lens. It's 6.5 m in primary mirrors, 2.7 times bigger than Hubble's. Imagine the detail it can detect, even the smallest flash of a star billions of light-years away, and then analyze the details of orbiting planets. What makes the James Webb Telescope revolutionary isn't just its observing power, but also its cutting-edge technology, including forward sensors and spectrographs. These instruments can do much more than observe. They can analyze and filter the unique light signatures produced or reflected by celestial objects to unravel their atmospheric conditions, composition, density, and even mass. Acting as a space investigator, they can determine if a planet has water, organic compounds, or even oxygen. The James Webb Space Telescope can address these inquiries, raising it from a simple observer to a scientific genius. It's not only an advancement over its predecessor, Hubble, it's more like a quantum leap. If Hubble's discovery stunned you, prepare for a veritable eruption of cosmic revelations. As we expand our view across the complex landscape of the universe, it's worth focusing on one specific star in the grand show, Proxima b. Since its discovery in 2016, this peculiar planet has stood out as a Shakespearean legend, loaded with complexity and riddles, captivating space specialists and astrobiologists alike. What's the fuss about? First and foremost, Proxima b is fundamentally in our galactic neighborhood, just 4.2 light-years from Earth. To place it in context, if you could beat the universal speed limit and travel at the speed of light, you would arrive in scarcely 4 years, about the same amount of time it takes for your favorite television show to fall into reruns. But we must dive deeper into why this proximity is so critical. We're talking about a universe that spans over 93 billion light-years from one end to the next, so finding a planet so close and so promising for scientific investigation is like discovering a hidden gem in a vast ocean. The significance of Proxima b lies not only in its proximity, but also in its potential habitability. This planet orbits within the habitable zone of its star, a region where conditions might be just right for liquid water to exist, essential for life as we know it. Its star, Proxima Centauri, is a red dwarf, and while such stars can be less stable than our Sun, the potential for life on Proxima b remains a tantalizing prospect. As researchers delve deeper into the characteristics of Proxima b, they are also keenly aware of the challenges presented by its environment. The intense stellar activity from red dwarfs, including flares and radiation bursts, could impact the planet's atmosphere and, by extension, its habitability. However, some scientists posit that if Proxima b has a robust magnetic field or sufficient atmospheric pressure, it could retain water and support life, albeit in forms that might be very different from what we recognize. The exploration of Proxima b is emblematic of a broader movement in astrobiology, an interdisciplinary effort combining astronomy, biology, and planetary science to understand how life might emerge elsewhere in the cosmos. Researchers are now looking at a wider array of conditions under which life might arise, leading to a more inclusive definition of habitability. This means considering not just Earth-like conditions, but also the unique environments of different celestial bodies. Advancements in technology play a crucial role in this exploration. Future missions aim to send probes to study Proxima b more closely. For instance, concepts like the Breakthrough Starshot initiative propose using light sails propelled by powerful ground-based lasers to reach nearby stars within a generation. Such missions could provide invaluable data about Proxima b and other exoplanets, enhancing our understanding of their atmospheres, surface conditions, and potential for life. As we consider the implications of discovering life beyond Earth, ethical questions arise. How would humanity react to the confirmation of extraterrestrial life? Would we seek to make contact, or would we adopt a more cautious approach to avoid potential harm to both ourselves and any alien civilizations? These questions emphasize the need for a framework of interstellar ethics as we venture further into the cosmos. The study of exoplanets like Proxima b also encourages a deeper reflection on our own planet. Understanding the conditions that support life elsewhere can inform conservation efforts on Earth, reminding us of the fragility of our environment. As we seek to uncover the mysteries of the universe, we are also called to protect our home and the diverse life it harbors. In summary, the quest for extraterrestrial life is not just about searching the stars. It's about understanding the intricate tapestry of life itself, its origins, its forms, and its potential futures. As we harness advanced technologies and foster international collaborations, the journey to discover life beyond our planet continues to inspire and challenge us. Each new finding, whether it be a faint signal from Proxima b or the discovery of an Earth-like exoplanet in the habitable zone of another star, brings us one step closer to answering the most profound questions of existence. Are we alone in the universe? What is life? And what does it mean to be human in the vastness of space?